Hi to all. In this video, we're going to see about two more solved problems on DC machines. Okay. First one, calculate the ampere turns for the air gap of a DC machine given the following data. Okay. Gross core length. That is length are given as a 40 centimeter. Air gap length is zero point 0.5 centimeter. Number of ducts is equal to 5. Okay, width of duct is equal to 1.0 centimeter. Slot pitch 6.5 centimeter. Slot opening is equal to zero point 0.5 centimeter. Average value of flux density in the air gap 0.63 T. Field form factor 0.7. Carter's coefficients 0.72 for opening. For gap length is equal to 2 and Carter's coefficient 0.82 for opening per gap length is equal to 1.0. Okay, in this problem, note that if the Carter's coefficient given in greater than 1.0, then it may be kgs, kgv or kg. If the Carter's coefficient given less than 1, then it may be del s or 1 minus del s or del v or 1 minus del v. Okay, therefore kgs, kv we are not or to be found out to find out kg when the ratio BOS by LG or BV by LG is less like 1, 2 or 3 and the Carter's coefficient given into close to 1.0, then it may be del S or del V. If it is close to 0, then it may be 1 minus del S or 1 minus del V. Okay, this is the problem. This is the data are given. So ATG is given as a 80,000. LG, kg, bg. Kg is Carter's gap expansion coefficient kgs into kgv. Kgs is equal to Carter's gap expansion coefficient for the slot lambda s by lambda s minus bg, bos minus 1 minus lambda s. So AT is equal to BOS by LG, that value 0.5 by 0.5 is equal to 1. And del S is equal to 0.82. Okay, kgs is equal to 6.5 divided by 6.5 minus 0.5 multiplied with 1 minus 0.2. That value kgs value will be 1.014. KGV Carter's gap expansion coefficient for the ducts L by L minus LV BV 1 minus del V. Okay, from the things AT BV by LG is equal to 1 divided by 0.5. That value will get 2 and del V value 0.72. KGV is equal to 40 by 40 minus 5 into 10, 5 into 1 into 1 minus 0.72. That value will be 1.04. Kg 1.014 and multiply with 1.04. The value will get of 1.054. Okay, maximum value of flux density in the air gap Bg is equal to BAV by KF. So BAV they given the value of 0.63. From that things 0.63 by 0.7 is a KF value. We will get the BG value 0.9 T. Okay, ATG is equal to 80,000 multiplied with 0.5 and 10 to the power of minus 2 into 1.054 and zero point 0.9 will get ATG value will be 3794.4. Okay, that's example 1 and example 2. Calculate the ampere turns required for the air gap of a DC machine gives the following data. Gross core length. Okay, in some problems they will give the values of air gap and length, and we should find the value of main dimensions like d and l. In some problems they will give the main dimensions values. From that things we should find the value of air gap length like that. Okay, so here the calculate the ampere turns required for the air gap of a DC machine given the following data. Cross sectional area length is equal to 40 centimeter and air gap length 0.5 centimeter. Number of ducts is equal to 5. Width of each duct 1 centimeter. Slot pitch 6.5 centimeter. Average value of flux density in the air gap 0.63 T. Field form factor 0.7. Carter's coefficient 0.82 for opening gap. Carter coefficient is equal to 0.82 for the opening gap of 1. Okay, for Carter coefficient 0.72 for opening gap of 2. Okay, here what they given, the ATG is equal to 80,000 IG LG kg BG. So Kg is equal to Carter's gap expansion coefficient. Kgs multiplied with KGV. So KGS is nothing but Carter's gap expansion coefficient for the slot. So lambda s by lambda s minus BOS multiplied with 1 minus del s. Since BV by LG is equal to 1 by 0.5, the value will get 2 corresponds to duct's opening gap length is equal to 1 must corresponds to slots. Therefore, opening of the slot BAS is equal to LG into 1. The value will get 0.5 centimeter. Okay, so AT is equal to BOS by LG. 0.5 by 0.5 will get 1 and del S is equal to 0.82. KGS is equal to 6.5 divided by 6.5 minus 0.5 into 1 minus 0.8. The value of KGS is equal to 1.014 is the KGS value, and we are going to find the value of KGV is equal to Carter's gap expansion coefficient for the ducts L by L minus NV BV and 1 minus del B. So at BV by LG 1 by 0.5 will get 2 and del V is equal to 0.72. Okay, KGV is equal to 40 40 divided by 40 minus 5 multiplied with 1 into 1 minus 0.72. That value of KGV will get 1.04. Okay, kg is equal to 1.014 multiplied with 1.04 will get 1.054. Okay, maximum value of flux density in the air gap Bg is equal to Bav by Kf. The value of 0.63 divided by 0.7 is equal to 0.9 T. Okay, so ATG is equal to 80,000 8 lakhs into 0.5 multiplied with 10 power minus 2 into 1.054 into 0.9 we'll get the value of 3794.4. Okay, so in some problems normally in we have to find the values of main dimensions from the values of air gap, specific magnetic loading, specific electric loading. There we should use the formula of B square. The PA is equal to C naught into D square L N. Okay, so there C naught is nothing but coefficient of output equation. D square L is the main dimensions. Okay, and N is a small n. That's the value will be small n. It's the RPS. So if you in the problem, if they given the value of RPM, normally they will give the value of RPM only. From the RPM, if you divide it by 60, we will get the value of RPS. That is the value of small n value. Okay, that thing so. Based on things, we should find the value of main dimensions length D and L. D and L are the main dimensions of the machines. Okay, so in psi value if they are not given, we should consider as a 0.68 to 0.7 value. Okay, one more thing for the solving the problems, if they are not mentioned the pole, okay, then we should consider as a square pole only. Okay, and so if they are not given the value of poles, we should consider as a square pole, and if they are not given the value of psi, we should consider as a 0.67 to 0.7 value, that psi values. Okay, and pole arc to pole pitch, the value the square pole value we should consider as a 1. Okay, so in this problem we have to find the value of ampere turns. Okay, so different types of problems they may ask for VTU exam also. Okay, from module 2, and if you want to answer the questions, if you want to answer that, you must read the questions twice. Okay, then you can easily understand what is present in that question, what they asked, and in the question also. Okay, so every time if the given problems, you must study or read the question twice and understand, and based on the questions you must answer for it. Thank you.